buddy. So we've been working with working with rational expressions, rational functions. Today we're going to look at solving rational equations. So we're going to have some equation that's got rational expressions, maybe on one side, maybe on both sides, and see what options we have to work with solving those. I'm going to show you one method. It's my favorite method. It's definitely not the only method, but it's one that pretty much always is going to work. So first of all, let's do a couple examples here and see how they go. First one we're going to have is r minus 4 over 5r equals 1 over 5r plus 1. Now, again, there's not just one way to do this. I see that both sides have this common denominator. Maybe I decide to do that. Actually, I take back what I said. I'm going to show you two methods because this one does work very nicely to use a shorter method. All of my fractions can be, I guess, eliminated. Get them without a fraction, without rational expressions, just by multiplying both sides by 5r, because my common denominator was 5r. So I go ahead and I say, well, that's 5r over 1. So that means 5r in the denominator, 5r in the numerator cancels out. On the left side, we're left with r minus 4 equals. On the right side, I have to distribute to both the parts. So I'm going to have 5r over 5r plus 5r times 1, which is 5r. So 5r over 5r right here simplifies to 1. I've got plus 5r equals r minus 4. Let's get our r's together. Minus r minus r. That's going to put all my r's on the right side. I'm going to go ahead and subtract 1 to move away from that right now. So looks like these two undo. These two undo. We're left with negative 5 equals 4r. And then we simply divide by 4. R equals negative 1 and 1/4. Not so bad. Okay, let's try another one. This one isn't going to quite work out quite as quick. And that option will still always work to find that common denominator, multiply both sides by that common denominator. So let's go with 1 equals 1 over x squared plus 2x plus x minus 1 over x. Now, if I'm going to use that method where I multiply both sides of my equation by my common denominator, it's a great method. But if I'm going to do that, I have to factor all of my denominators first. So over here on the left side, 1, well, that's just 1 over 1. This second fraction, first fraction on the right side of my equal sign, I've got a common factor of an x from those two terms. So I'm going to get x times x plus 2 plus my final fraction. I can't simplify, I can't factor any of that. So I go ahead and I come over here to the right side and I say my least common denominator is, well, x times x plus 2 from that one. This one's only got a 1. I don't need to worry about anything there. This one's got an x. I've already got an x in my least common denominator. That's great. I'm going to go ahead and I'm going to multiply both sides of my equation by x times x plus 2. X times x plus 2. Now, when I use this method, it can get a little cumbersome at times. So this is the first method I showed. I'm going to show you a second method here in just a little bit. So on the left side, it looks like I get x times x plus 2 equals. I distribute in here. I get x times x plus 2 times 1. I don't need to write the times 1 over my denominator that I had before. X times x plus 2 plus, oh, I've got this mess, x minus 1 over x times x plus 2. I'm going to write that over 1 when I distribute into that piece right there. Okay, so now I'm going to go ahead and I'm going to simplify. And on the left side, nothing simplifies, but I am going to go ahead and distribute so that I can start to combine like terms, move x's from this one side to the other. X squared plus 2x. This middle section looks like they're going to simplify out, and that's going to give us 1 plus. Okay, so I'm looking numerator to denominator. X cancels out with x. And I'm left with x minus 1 times x plus 2. I'm going to have to FOIL those, but that's okay. So left side, bringing the left side along. x squared plus 2x equals, let's bring this 1 down, plus FOIL x squared plus 2x, but minus 1x would give us plus 1x minus 2. Combine some like terms. I'm going to move all my x's to the right side, so I'm going to subtract x squared and I'm going to subtract 2x. And maybe that wasn't a great choice, but we'll see what happens. I get 0 equals, let's see, looks like I've got my x squareds cancel each other out. 1x and minus 2x gives me negative x. Negative 2 and positive 1 gives me negative 1. So I'm going to go ahead and I'm going to add x to both sides. So I get a positive x. X equals negative 1. Alright, so there's one option with our common denominator, multiplying both sides by our common denominator. We will do another method in a second video.